As a gas with partial pressure of the gas equals 615 millimeters of mercury, and here's the gas, by the way, it's in this little area, is contained in the U-tube as shown to the right. Oops, it's below for this one. If the height here is 65 millimeters, what is the atmospheric pressure? There it is at the bottom, pressure of atmosphere. And this is going to be a multiple choice question. And I'd like to talk about the philosophy of this one before I actually solve it. So first off, this is mercury, and mercury is a liquid. So we will often see it referred to as Hg, its chemical symbol, with the L for liquid. And mercury is only one of two liquids that elements exist as on the periodic table. The other one is bromine, which is Br2. And not that you have to know this, but bromine is one of our diatomics, and it is a liquid. Anyway, there are only two liquids. Mercury is the liquid that you'll see a lot in the gases chapter, and that's because we measure pressure in terms of millimeters of mercury. And really what's happening here is that this gas, the molecules, whatever it is, or the atoms, the particles, are colliding with this mercury to push it. And the atmospheric molecules are colliding with this mercury to push it. And so far what we're seeing in this situation is that the atmosphere is pushing the mercury farther down the tube than the gas. And what that means, so the atmosphere pushes the liquid mercury farther down the tube than the gas. Okay, and because it's pushing farther, it must have a higher pressure. So P ATM must be greater than P gas. And we'll do a counter example in a minute. Now, another thing is that millimeters of mercury is a measurement of pressure. And in the lecture outline videos, we said 1 atmosphere, which is the pressure of the atmosphere at sea level, is 760 millimeters of mercury. And what's really nice about mercury is that since it's a liquid, it can move in response to pressures. And I don't know if you've ever seen a mercury thermometer, but that's one of the reasons mercury was used in thermometers as well. Anyway, so we've got this height difference. And so the equation we want to use, the equation I always start with is, so the atmospheric pressure will be equal to the gas pressure plus the height of the liquid mercury. And I put plus the height of the liquid mercury on this side because I know the pressure of the atmosphere is larger than the pressure of the gas, because the atmosphere can push the liquid mercury farther. And once I get that, I know the pressure of the gas. It's 615 millimeters of mercury. And I know the height of the mercury, the height difference, if you will, and it's 65 millimeters of mercury. And then if I add these two up, I get my pressure of my atmosphere. And I get a 680. Which is an answer. True. And This one has a very small pool of questions, so you may encounter this question. Are there any questions about this process for this question?
Professor, would you use that same equation if the atmosphere was less than the gas?
Okay, so great question, Mary. I'm going to do that right now. So I seem to be flipping these pages over a lot and working counterexamples this time, but that's a very important question, so I'd like to go over it. So I'm going to sketch my YouTube. My YouTube, not where you post videos. It's a whole other YouTube. Okay, so now my gas is going to be right here. And my atmosphere is going to be there, and I'm going to sort of hatch in my mercury. And now my height difference, oh, and here's my gas, P gas. And my height difference. That's an H. There we go. Okay, so this is the counter example, or the opposite case. And from this picture, my process for solving this goes like this. So by looking at this picture, the gas is able to push the mercury farther down the tube than the atmosphere. So I know the pressure of my gas must be higher than the pressure of my atmosphere. And there are a couple different ways to do it, but I always like positive numbers if I can deal with them. So I've assembled this process so that I can do that. Because I know that the partial pressure of my gas, time to go to my backup pen. There we go. My partial pressure of my gas is now equal to the partial pressure of my atmosphere plus my mercury, my height of my mercury. And so that keeps it as a positive sign. And so the process, which can be confusing for this, but is find out which one is bigger, and then add the mercury to the other one to get the bigger one. And so if I were to put some numbers to this, I would say, well, we can do whatever one we want, but what typically happens in these is you can measure the pressure of the atmosphere, and it's typically something like, let's say, 745 millimeters of mercury. And then you can measure the height with a ruler. I was actually using my ruler upstairs, so I don't have mine with me. But let's say the height was 83 millimeters of mercury. Now I know that my pressure of my gas has to be the sum of these. And sort of, again, my concept here is, so critically think about which one has to be larger, and then make sure that your answer reflects that. So, because there are different ways to do this, and then whatever you get to your answer, so I know that this is going to be larger because I'm adding something to it. And then it's just, because the math on these is super simple. It's just addition. The hard part is making sure you've got your setup correct. So, Mary, and if anybody else had any questions, I hope that shows what a counterexample would look like. And the third example, of course, is if they're the same, and in which case you know that the two pressures would be equal to each other.
Okay, and it doesn't matter which one is the closed end or open end, whether it's the gas or the atmosphere with that in that tube.
It really, so as far as the process goes, it really doesn't matter. Um, so so whichever one, again, this is my process, but I think whichever one pushes the mercury farther has to be the bigger one. And so it's pushing it farther down the tube. Yeah. But, and I'm happy to do other examples too if you have an example you'd like me to draw or think about.
So I have a question, Professor.
So I think Michael, go ahead first, and then Mohammed.
It's okay. He's probably going to ask what I'm asking, so he can go ahead.
Mohammed, go ahead. Yeah, no.
Yeah,
So
I just want to know if we always have to add. We don't have to never multiply. We always have to add.
this one is always an add type problem, right?
Okay, please.
I mean, I guess so. So in theory, once you get the millimeters of mercury, so we'll see that oftentimes, but not this problem, you take the millimeters of mercury and you divide them to get atmospheres, but that's not for this problem. We'll see that coming up.
For this one, like I only seen two numbers, and it's a multiple choice question, so I just did it for example, the first one 615 plus 65, and I have the 680 instead of going through all that stuff.
Yes,
that's what I'm just asking.
That's all you have to do for this one.
All right, thank you.
Yep.
So this is not collecting a gas.
This is not collecting a gas.
Because we're not using water, but because you just said that the enclosed portion doesn't matter, right?
Right.
Which in the picture, but it does matter when we're collecting a gas.
That's right. So, and I don't know. I think I saved the collecting a gas question for next homework. Collecting a gas over water. But
it just threw me off when you said that it doesn't matter. My mind went to the lecture portion of collecting a gas, but we're using mercury. We use water in that one, so never mind.
You got it.
Yeah.
Good.
Right.
Any other questions? Okay.